Okay, well,
Probably got one.
I'm not sure what all we got there. We got the whole process, but that's okay. Okay, so the question is, I did 35 flips, and you as a class each did 5 flips, but we got 35 flips out of that. And this corresponds to this. Notice when I got this one, you got this one. When I got this one, you got this one. Your position in the array is the same as my position in the array, right? Whatever the class as a whole got. Okay? Now, question. How many heads, if you had to guess, without looking at the thing, do you think we got?
40.
Okay, well, what's the most likely number?
35.
Okay? How much less likely do you think 40 is than 35? Just based on your long experience of
40,
coin flipping.
No. 60%.
You said about 1 out of 70, right? Well, we'll be able to test that and see what the probability is, assuming the coins are fair, which they really aren't, but they're close enough for this sample size.
Why is one side heavier than the other?
Again?
Why is one side heavier than the other?
Well, one has a head, one has a tail. They're stamped differently.
The head's always going to be heavier.
Not necessarily. Depends on how deep you stamp it and, you know, how much detail you have in the tail. So you'd have to analyze, you'd have to do a lot of measuring to figure it out, or you'd have to flip the coin a couple million times and see how it comes out. Because you flip it a couple million times, you can actually kind of determine how much heavier one side is than the other, because one side's going to come up a little more than the other. Okay, well, that's irrelevant. We're not going to get into that. Just I'm saying that these aren't really fair coins. Okay? If you had a fair coin, it would be blank on both sides, and maybe then you put a little mark on this side and a little mark of equal weight on the other side, right? But different marks, okay? Like a plus sign here and 2 minus signs there. And make sure the center of mass is, you know, all the moments and that stuff. You don't know what I mean. So, okay. So, yeah, we could talk about moments. That would be fun, but I don't think we're going to get to it. But I got to remember to put that on the final. Okay, now.
Forgot part. Put what on the final?
Moments. Just remember that. Remind me to put moments in the final. Okay, now. You're saying that 35 is most likely and 40 heads would be, you know, total 40 heads is going to be somewhat less likely than that, right? Okay? And actually, there's a normal curve. If you have the right numbers here, that would give you the relative probabilities. In other words, if the number here is 35, then how high the curve is here kind of indicates how likely 35 is, okay? And maybe 38 is here. You know, a little less than half as likely as 35. And maybe 40 is out here. Do you understand what I just told you?
You just probably just graphed the.
In other words, if the normal curve has 35, 38, and 40 here, then the graph altitude here tells you the ratio of the graph altitudes, this altitude to this altitude, sort of tells you how much more likely 35 is than 38, and how much either one of these is more likely than 40, right? Now that's not exactly how it works, but that's kind of intuitively the way you look at it. You're really looking at areas of trapezoids. And we're going to analyze the normal curve of trapezoids. And it's actually quite easy to do that once you know how to do the graphs. And we're going to interpret the trapezoidal graph in terms of this sort of thing. So we can answer that sort of question. Yes, Corey?
Do you know when lunch is?
Yeah, it's going to be probably about 20 after 12. Okay? Because we're going to take a break here soon, then we're going to come back and do a little more. But we want to kind of discuss this. Okay. So, well, let's count them. Okay? And we'll divide the task up.
If,
Okay?
If we were to take the average of all of those coin flips would it all round up to about 0.5 or 1/2? 50% of each side?
Well, 50% of them, about 50% should be heads. Okay, now if you count the number of heads and tails here, well, you can see if from 2 heads or 2 tails, there's no difference. We got head, tail 1 time, tail, head 2 times, so we got more tails than we got heads. 1 more tail than we got heads here, so if you count them up, there's 16 of them. So it's 9 tails and 7 heads. And from this distribution, I can conclude that, and if you count them, if I did it right, and if my reasoning is correct, which was just done off the top of my head, but seems pretty obvious, okay? You want to check it out by actually counting them. Now we're going to count these, and in order, 1, 2, 3, 4, 5, 6, 7, going to count the corresponding row. So in other words, Joanne will count the first row, Corbin the second row, and so forth. Right?
Yes.
So, how many heads do you get in your row? Count it quick.
Wait, including your row and our row?
Yeah, the whole row all the way across.
Yes, sir.
5. for me.
Okay, well, count them.
Oh.
Give everybody a minute, and then we'll
How
just
many
say the
heads?
numbers.
1.
Okay, everybody got the number?
No.
Okay. Joanne, you said 5, right?
Yes.
Okay, next.
5.
I messed up.
Next.
7.
7. Next.
Hang on, I messed up.
Hang on. Okay, next.
5.
5. Next.
Oh, wait. I thought that was.
Huh? You say 3?
Which row are you on?
How many heads do you get? Well, you're this row, right?
Yeah, but I'm the next one up, so.
Yeah, but you didn't have yours, so we'll get you in a minute. Okay.
Yeah, I'm 7 then. 7, sorry.
7. 7.
7 heads? Yeah.
Yeah, okay, that's right there. 14 across there. Okay, next.
5.
5. Next.
5.
Again?
5.
5. Okay. Next.
I got it. It's 5 heads.
5. Okay, so the total number of heads, we got 1, 2, 3, 4, 5 5s, which is 25, and 2 7s, which is 14. That's 39, isn't it? Now we could check ourselves by also counting the tails and have different people count the same row, but count the tails and see if the 2 numbers here would then match up
I counted the tails on mine too.
to give you 10, right?
If
Make
you have
sense?
5 heads, and you've already know that you got 5 tails. So, all you gotta do is subtract.
That's what I said, you count them. You don't bias the thing with your wrong count, in case your count is wrong. Now, we're not gonna calculate the number of tails here if we're trying to check our count. You know, you're just automatically gonna get a total of 10 if you subtract. So a different person will count each row. Let's go ahead and do this, just to make sure we understand it, okay? And this time, you count the first, second, third, fourth,
That's still my row.
fifth, sixth, seventh rows in reverse order.
Uh,
Everybody know what row they're counting?
We're counting heads.
Huh?
Counting heads.
Mr.
Counting tails.
Okay.
It doesn't matter.
You're gonna count tails.
It doesn't matter.
Everybody count tails in the row that I just assigned. Go. You got them?
Yeah.
Okay, first row.
5.
5. Second row.
5.
5. Third row.
3.
3. Fourth row.
5.
Fifth row.
3.
Sixth row.
5!
Seventh row.
5.
Yeah, that was good. I heard all those. Some of them I heard, I'm still hearing. They're kind of reverberating.
Mr. Smith,
Yes.
you give me my row again.
Huh?
You give me the same row again.
Okay, so we know that these 2 counts must be wrong.
What?
No, we don't.
The
No, we
fourth
don't.
row, no, it's 10.
Yeah, that's right. Yeah, I thought about that, and I said, no, that'll work. There's an odd number of people here. Well, that means the middle guy gets the same one, and I know that. I just
So you
didn't
just
think
trying to
about
give
it.
me
Anyhow,
one.
we got 39 heads, okay? Which means we got 31 tails, right? Make sense? Now, we could go through this first column and count how many times we got heads, tails, how many times we got tails, heads, how many times we got what, right? And that wouldn't take long if everybody counts one row at a time, but we'll do that when we come back because it's past time for a break. Come back at 10 till,
At what?
and we'll break at 20 after for lunch.